What's up? What's up? It's your man Jimmy Chan. So today we are going to be talking about normal distribution. Okay, so in normal distribution, reset this back to normal here, is where you're going to see a 68, 95, 99.7 rule. So it says approximately 68% of the data items fall within one standard deviation of the mean in both directions. So what that is saying is, I'm going to show it to you right here, right, with the red area, okay? So what typically happens is that right here is the mean, right in the center, right, is the mean. And to each side, there is one standard deviation. So this percentage of people in this shaded area, or I should say the area under the curve, is 68%. Now, is it divided evenly? Yes, it is. So you could say that each side of that shaded is 34%, because this whole shaded area is 68%, okay? Now, if you look, the next one says 95%. So 95% of the data items fall within two standard deviations of the mean, right? So again, if you look at the blue here, this is, again, the center is the mean, okay? In fact, let's go ahead and put down X bar right here. And on top here, I want to do the same thing. I'm going to call this X bar right in the center, okay? That is my mean. And this would mean that I have two standard deviations above the mean and two standard deviations below the mean. Okay, so these means that I'm adding one or two standard deviations to it, and this would be subtracting two standard deviations to it, and that will get me a certain score. Okay, this whole blue area is 95%. Okay, the whole blue area is 95%. But again, I know that in here is 68%. So the question is, what's left over with all the 95%, right? So I know that this is 34. I know that this is 34. So the question is, what's left over here? So I can take the 95%, subtract the 68%, right? So let's go ahead and do that. 95 minus 68. I'm going to have 27% left between here and here. And if I break those two in half, I'm going to have 13.5% left. Okay? So each section itself has these certain percentages. Okay? So in total, so if you add these percentages up, you'll get 95%, and 95% is also known as the area under this curve. All right? So let me go back here and write this as 68%. And then there's one more. The 99.7% of the data items fall within three standard deviations away. So it'll be this purple one right here. Okay? So again, I have this part here is the mean. This is the area under the curve is 99.7%. That means everything that's colored in purple covers 99.7%. Okay? So what I already know is that this is 34%. This is 34%. Oops. This right here is 13.5. This is also 13.5, which I know that these four numbers here add together to give me 95%. So what I can do is take the 99.7 and subtract the 95, and I get 4.7 left. So therefore, I'm going to have to make this smaller here. So if I divide that by 2, I'm going to get this is going to be 2.35%. So that means this is going to be 2.35% in that little thing. So again, the whole purple, 99.7. This little tiny piece right here, 2.35. This bigger piece, 13.5. This really big piece is 34%. Okay? So this is always a consistent rule with normal distribution. Okay? So anytime you hear that data is normal, then you're going to think of the 68, 95, 99.7 rule. Okay? So I made one last thing, right? I made this thing right here that has all sorts of different colors. Okay? So we're going to label every single different section, because what if it was more than 3 standard deviations away, right? I have this shaded in gray. I know it's hard to see, but this gray area has a certain percentage as well. What are those percentages, right? So let's go ahead and fill all these in. I know that this is 34%. Actually, let me... This is 34%. The orange and the blue is going to be what? Correct. It's going to be 13.5% and 13.5%. Okay. The purple and the red is going to be what? It's going to be 2.35. And the little tiny gray area right there, and the little tiny gray area right here is going to be what? It's going to be the leftover of 0.15%. Okay. Now, what you can do is add all of these numbers up, and you will get a total of 100%. Okay. So, but the 68, the 95, and the 99.7 is what you're going to have to know. All right. And then you're going to be able, and the other part of it is that you're going to need to be able to calculate these percentages here, because they're going to want to know what these percentages are going to be, because they might ask you for 1 standard deviation below, but yet 2 standard deviation above, and ask you what that area under the curve is. So you do 34 plus 34 plus 13.5, right? All right, so let's get into some problems so that maybe we can put all of this and make sense of everything here, okay? So it says the scores on a test are normally distributed. Keywords, right? Normally distributed, with a mean of 110 and a standard deviation of 22, okay? It says find the score that is 1 1/2 standard deviations below the mean. 1 1/2 standard deviations below the mean. Okay, so this is kind of important here. So I'm going to do this, and then I'm going to do this right here. Okay, that means below the mean. So first thing I'm going to do is this. Number 1, I already said that the center is the mean. So that is going to be 110. Okay, so X bar is equal to 110. Okay, the standard deviation, I'm just going to label it as SD, or actually I'm just going to label it as S, is equal to 22. Okay, so if I did 110 plus 22, I'm going to get 132. So 132 would go right here. Okay, so how I did that was and then if I add 22 more, I get what? 154. Add 22 again, I get 176. Okay, so let me just try to make this better here. So to go from here to here, I did 110 plus 22. And then from 132 to 154, I did 132 plus 22. Then from 154 to 176, I took 154 and added 22 to that. To get 176. Okay? So that's the way you do that. Now, what if I want to go below? Well, then I have to take the 110 and subtract 22. Yeah, I'll get 88. Okay, and then I take the 88 and subtract another 22. And what do I get? 66. Now I take the 66 and subtract 22. And what do I get? 44. All right, so now I have all my numbers that I need. Okay, so that's the reason why the X bar or the mean is needed and the standard deviation is needed, so I know how to fill this out. Well, it wants to find 1.5 standard deviations below. Okay, so when I look at it, here is 1 standard deviation below the mean. I want 1.5. So what is between 66 and 22? So I'm looking for this right here, right? I want to know what this score is going to be. So it's not asking for percentage. It wants to find the score, okay? It's not asking for percentage under the curve. It's asking for the score. So what's between 66 and 88? Well, you can do two things. You could add these two numbers, 66 plus 88, and then divide that by 2 to get 77. Okay, so let me go ahead and shorten this out so that you guys can see what I'm looking for. So this is 1.5. So let me see here. I had to do 66 plus 88 and then divide it by 2, right? So let me go ahead and draw, oopsies. Let me draw this line here. 1.5 below. Okay, 1.5 below the mean is between 66 and 88, so that's how I got to 77. Okie doke. All right, so now how about this one right here? It says not everyone pays the same price for the same model of a car. The prices paid for a particular model of a new car is normally distributed. Okay, again, we got normally distributed. Awesome. I have the mean of 21,000. Okay. X bar 21,000. And I have a standard deviation of 2,000. So S equals 2,000. And it tells me to go ahead and use this and find what percentage. So now I'm looking for area under the curve of between these two prices here. So wherever the prices are here, what is the area under that curve, okay? So again, what is the mean? The mean is 21,000, okay? So that means this middle number here is 21,000. So if I add $2,000, that'll be 23,000. Add 2 more, it'll be 25,000. Add 2 more, it'll be 27,000. If I subtract 2,000 from the 2,100, it'd be 19,000. Subtract 2 more thousand, it'll be 17,000. Subtract 2 more thousand, it will be 15,000. Okay? So what it wants is, hey, what is the percentage of buyers paid between 21,000 and 25,000? So I'm looking for this area under this curve right here from 21,000 to 25,000, right? So that is the area under the curve I'm looking for, all right? So what does that involve? Well, let's see here. If we remember the percentage is right. This was 34%. What was that little one? Wasn't it 13.5%? Well, yes, it was. So to find the percentage, I would just take the 34% and add it to the 13.5%. And what do I get? 34 plus 13.5 gives me a 47.5%. And there we go. All right. All right. Let's see what else is here. Computing z-scores. All right, so a z-score is essentially, it's also applied to normal distribution. A z-score is kind of like a standard score, so that you're not, so it standardizes all these numbers so that I don't have to use this, nor do I have to use these. So I won't say the mean is 1,000 or the mean is 21,000 and this is a standard deviation. We already know that the mean is going to just be your 0, okay? And then everything else is how many standard deviations away. All right, so either I'm going to have to find the z-score or I'm going to have to find what the amount is, what the data amount is. But I'm still going to be given the mean and the standard deviation, okay? So this is the formula for z-scores. So let's take a look at a problem. It says a set of data items are normally distributed, all right, with a mean of 50, interesting, and a standard deviation of 7. It tells me to convert 56 to a z-score, okay? So I'm looking for a z-score. So clearly from here, I want to convert to a z-score. So I'm looking at z, and that's going to equal to the data item. The data item that I'm looking for is 56 minus the mean. The mean is 50. And divide that by the standard deviation, and the standard deviation is 7. So again, remember that I had my x bar being 50 and my s equaling to 7, okay? So my z is going to be 6 over 7, which is going to be approximately 0.86, okay? And that would be my z-score, okay? And you're going to have a table that you can look that up in terms of what that means, all right? All right, let's continue on. A set of data is normally distributed. Interesting. The mean is 500, and the standard deviation of 30. Okay, so x bar, 500, standard deviation, 30. Find the data item. So I'm looking for the data item. In this distribution that corresponds to a z-score, z equals 8, okay? So what I'm really looking for is the data item, okay? So z is equal to the data item, we'll call it d, minus x bar divided by the standard deviation, right? Okay. So let's go and fill this out. So let me see. I have a z-score. That was 8. And that's going to equal to the data item is what I'm looking for, minus the standard deviation. Minus the mean, which is 500, divided by the standard deviation, which is 30. Uh-oh. So how do I go about doing this? So number one, there's 2 different ways of doing this, but I'm going to stay consistent with how I teach rational equations. So this is a fraction and this is an equation, okay? So what I'm going to go ahead and do is I'm going to go ahead and move this to the side here so I can show you a little bit more. So what I'm going to do is I'm going to duplicate this. What I'm going to do is I'm going to move the 8 up and I'm going to put it over 1. Because I'm going to make any fraction, any number a fraction. So I'm going to put it over 1. And then I want to get common denominators. So the denominator that I need to get, the 1 is missing, which I bring in the sisters, right? This already has a denominator 30. This has a denominator 1, so I can make the 1 look like the 30 by multiplying top and bottom by 30. And if I look at the denominator, 30 times 1 is 30, and 30 is 30, okay? And since this is an equation, what I can do is, since with an equation, if the bottom is the same, that means the tops must be the same. So what do I get here? I actually get 30 times 8, which is 240, is going to equal to d minus 500. So what's the data item going to equal to? Well, add 500 to both sides. I'm going to get 740. So that is the score. That is the data item that I'm actually looking for. That is actually corresponds to z equals 8. All right, and there you go. And I hope that helps. Any questions, let me know. See ya. Bye.